microphone.
Okay, yeah, you just have to put it because he's recording the seminar.
Just for his purpose.
Just for his recording. Yeah.
Not really to them.
Okay. Now here is small class. So
sure.
Okay, can I do the introduction now?
Sure,
Are you
sure,
ready?
Go ahead.
Okay. Good afternoon, everyone. Welcome to our EECS seminar. So today we are really delighted to have Dr. Weisong from Wayne State University with us. He's going to talk about vehicle computing, vision, and challenges. So a brief introduction of our speaker today. Dr. Shi is the Associate Dean for Research and Graduate Studies at the College of Engineering, Wayne State University. He is Charles Gershenson Distinguished Faculty Fellow and a Professor of Computer Science. Over there, leads the Wayne Mobility Initiative and directs the Connected and Autonomous Research Lab over there, investing performance, reliability, power, and energy efficiency, trust and privacy issues of network computer systems and application. Dr. Shi is one of the world leaders in the edge computing research community. His pioneer paper entitled Edge Computing, Vision and Challenges has been cited for more than 4,400 times. So Dr. Shi has been actively involved in the activities of IEEE Computer Society. He had served as the chair of the technical committee on the Internet Committee on the Internet during 2012 to 2016. He is the Conference and Connected and Autonomous Driving. He is an IEEE Fellow and an ACM Distinguished Scientist. So with this introduction, please join me to welcome Dr. Shi for his seminar today.
Thank you very much for the nice introduction. So now I realize I really should cut this intro. So it's too long for him to read this. Well, it's a great pleasure to be here, and I was just very impressed. It's the first time, during this pandemic, I give a talk in front of such a big audience. I was give a talk at the University of Delaware last week, and then, but most of the, people is online, so it's not really like this. So it's quite impressive. So like Professor Abbas just mentioned, so I'm from Wayne State. So I just take this quick, this opportunity to give you an idea about, where is Wayne State, and then it's about our department. So I have been drive through Toledo for many, many times. So that, but this is the first time actually visiting your beautiful campus. So I think this is, the architecture and the infrastructure here is really nice. So congratulations to you guys for the students here. Since you have two screens here, I will majorly using this. Occasionally, I will use the other one. Okay. So basically, that we are in Detroit, right? Probably about 60 miles from here, and then that Detroit. This is the view from my office, by the way. Do you believe that? Many of you probably don't, but next time I will invite some, the faculty and chair to visit. That's very close to where my view in my office, because I'm on the 14th floor for one of the buildings in the middle town. So basically, from office I can see the Detroit Tigers Stadium. This is the big, the billboard, the board. So you basically, when there's a game, I can see that. So that's just give you an idea about what Detroit look like from the Middletown point of view. And then it's I quoted it called America's greatest comeback city, because we are not far away from here. If you are in computer science, for example, I mentioned it to the chair and during the lunch, Amazon Detroit is growing so fast. They're starting with 3 people. One of my students was one of the earliest people there, but today they already have 450 employees, and this year they have 120 openings. So if you guys graduate from Detroit from here, you can consider that also an opportunity there. There's a lot of movement right now is in Detroit. Google is moving their Midwest headquarters here, Microsoft and Amazon. There's a lot of things there. So in terms of based on NSF, funding, so Wayne State is considered as a top 50 public university in terms of research R&D. So like this year, 2021, the university's total R&D is $320 million. So that was the current the situation. So just to give you an idea about that, and the School of Medicine, College of Nursing, College of Engineering, I view them, basically it's kind of the three pretty heavily, actively, involved in the research. And here is myself is come from computer science. So we have a computer science. We have right now 22 tenure track faculty members and 5 NSF career word. We have one just got in the last, but we lost one because he moved to another university. So that's why we sort of balanced here. So I just show you that the view, because this is where computer science is. This is the building. This building is about 100 years now. So my office is here. It's in the middle of the top floor. That's why that it is very close to the view on this where we look at the city of Detroit. So just to give you an idea about where Wayne State is. Okay, so now next, here is today's talk. I want to take this opportunity that I believe Toledo, because when we drive from Michigan to here, the first one you saw is a big plant here. I think it's a Chrysler's plant, right? I'm not sure which plant it is. It's a Jeep or somewhere. So good. So we all benefit from these 3 big autos, OEMs, and then we have about more than 100 tier 1 suppliers in this region. So that's why that we are very actively working in this. But today I want to share you something. Why EECS students today is so excited about this field. Let me tell you a story. So when people ask me, yesterday when I was visiting Oakland County Road Commissioner, the manager asked me that, why do you want to visit us? And I said, you are right. That you should ask yourself, why do you want to host me? And then he's smiling to me. The reason is, have you thought about a traditional civil engineering, traffic management, all these traffic and nice people now is working with computer science with us? No, we don't even talk to each other. We speak different languages. And the same thing is, I've been at Wayne State for 20 years. In my first 15 years, I never talked to the automakers because they don't care about us. I don't care about what they are doing because you are doing those kind of mechanical stuff, right? But in the last 5 years, things changed significantly. So I'm going to mention today, if you haven't been aware of this, you will see the future of the vehicle will be revolutionary change. So think about that. If you want to take something back, take out from today's talk, is the following. In the last century, 100 years, when Henry Ford starting this stuff, vehicle is only a transportation tool. But in the next century, vehicle is not just a transportation tool. Vehicle will be like a mobile sensor. It will be completely changing, the way how the transportation system has been built. That's why we're so excited about you choosing the right discipline here. No offense to any other disciplines, but I'm just saying this is the right time, right area you're working on. So here is what I want to talk about: why vehicle computing, and then we were talking a little bit about how we, as a computer science people, working in this edge intelligence and etc. So take a look at this. This is the vehicle that in our lab we sort of assembled. I don't even call this a vehicle. I call it platform. The reason is the following. This vehicle is a 2017 Ford Fusion. The cost is $20K. But do you know how much this platform cost? The vehicle itself is, when we build this, the vehicle is only 1/10 of this whole platform, the cost of the platform. So that just give you an idea that why? It's because, look at this one, you can see the vehicle itself is just $20K there, okay, a little bit more than that, but then putting all these sensors, for example, one of the sensors on top of this Velodyne sensor, the cheapest one, okay, today is 2022, but by the time when we have this, the cheapest one on the market is $15K. It's just one of these LiDAR sensors. Today, if you want to have for example, have a 128 line via LiDAR sensor, it costs $80,000. Just the one sensor sitting there. So this double E, right? That's basically you guys working on sensors. That is the whole world right now is companies they are trying to design how do we reduce the cost. how do we improve the technology using optical, using SSD, using all kinds of technology. So that was one thing it's going to change. And this is going to show you that if you're looking for this platform itself, you can see where, compared with different from mechanics, you used to think about a vehicle. You see those, for example, sensing. You rely on all these kind of sensors here, and you need an algorithm here to do the sensor fusion to make a decision. For example, where is the vehicle right now? Right? So the location is important, and then you need to detect the pedestrian signs. There are many things. Next thing is about, I mentioned this, perception here, that you need to combine these things together to decide, how make some sort of a percept where you are, and then your surrounding environment. Eventually, you make a decision here. How do you, moving forward? Pretty much all of this, including algorithms, you learn here. Path planning, optimization, and etc. This is not enough, because now all these things is running, executed on the vehicle. Then the computing platform became super important. So just to give you an idea, the latest one coming from NVIDIA. NVIDIA has been invested heavily, GPU, right? Most of you heard about GPU. That's the company right now is heavily invested in this, they call it DriveWorks. The latest computing platform designed by NVIDIA cost $25,000. So if you just buy one of these, put it on your BMW, for example, that's the computing equipment. So now you got an idea that vehicle itself is become not really important anymore. The sensors, the computing equipment. So now let's talk about one more thing. EE students will be very interested is about the communication. We talk about connected vehicles. Connected vehicle, you need to have traditionally 5G, 4G, right? Those are the traditional ones. But now there are people talking about the CV2X, cellular vehicle to X. Today, the company recently just delayed 2 sets of RSU to us, roadside unit and onboard unit with the CV2X to us. If I purchase this, one set costs $15K US dollars. Just one set of RSU and OBU for this communication. So that's argument. Don't take this like the final price, because once this go to mass production, the price will be dropping. But just to give you an idea about that, when this is it's expensive, it means it's new, right? It's an opportunity here. So you can do the research, easily doing the master thesis, PhD research. You can do a lot of things here. It's all the new area right now. People are working on it. So that's about the computing stuff here. And then if you are doing the computer science, traditionally we need an operating system. So what is the future operating system on a vehicle going to look like? Traditionally, a vehicle is just have a CAN bus, very simple sort of operating using called a vector. But the next generation of operating system will be tremendously different. So we need not just a real-time system. Real-time is not necessarily good enough. You also need to have computing power, manage the isolation, security. So that's why I really like this, this area is basically, now after you heard from me, is a vehicle is just a mobile computer. You can think it's a computer with the wheels, right? That is with a lot of sensors, so you can doing, sensing the surrounding environment. So that's just to give you a view about what's going on the vehicle. That is just the beginning of the story. Because the vehicle, by sooner, you will see that actually from the Toyota's goal is by 2025, almost all the new vehicles produced are connected vehicles. So what does that mean to us? That means your vehicle is not just sitting here as a standalone. It will change the whole business model of the vehicle automotive industry. So I will have a picture here later to show you that what's the business model potentially. But I can give you a little bit of taste at the beginning, because your professor maybe already tell you that during a talk, only first 5 to 10 minutes is important, and then you can go to sleep if you feel tired. Okay, so I need to deliver that message to you. So as a vehicle, right now, for example, most of you probably drive a vehicle, right? So what's the business model? You go to a dealership, you buy a vehicle. That's it. You own this for the rest of your life. In the future, that's not going to be the way you own a vehicle. Vehicle sell to you, let's say 20K. And then you will continuously buy new function. For example, if you drive a Tesla, you know that earlier last month, Tesla increased autopilot. Autopilot, if you have a Tesla, doesn't mean that you can do autonomous driving. You need to pay extra $12,000 to buy an autopilot. Then your vehicle starting can do it. But do you really need to change anything on the vehicle? You don't. So what you need is download the autopilot software, then just deploy it. Then now your vehicle became like an autonomous vehicle. Right? That's the business model for the future vehicle will be vehicle itself only cost a very small portion of that. And then you as a user can just grab, oh, I like this function, get it. You like other function, get it. Then you keep paying more and more money for each of these single functions. So eventually you and I could have a same vehicle, but it's completely different. So that's where this eventually the business model behind these connected vehicles. It's because the connected vehicle have made this much simpler. So that was the idea that you can see what's the future of the auto industry. So let's tell you another interesting story. One of my part-time PhD students is from GM. Two months ago, he told me, Dr. Shi, recently I being reorganized, and I asked her, which department are you in? She said, now I'm in a very exciting department called software-defined vehicle. Then I asked her, do you know what are you guys doing? She said, no, none of us know what our job is. We just realized software-defined vehicle is the future. Very hot topic is the future. Every single automakers today is create a department called a big department, not a small one, because you're going to see that the mechanical part is getting shrink, smaller and smaller. But the software-defined vehicles are getting bigger and bigger. And some of them don't even know what their really job is. What is a software-defined vehicle? But the company is already reorganized. This is amazing. You know that those big companies, normally they don't like to reorganize this fast. But this is the first time I heard from GM, Ford. They are starting reorganized. They don't even know what this really is about. So that just give you an idea how important of this connected vehicle going to change the future of this whole industry. So since I'm here to talk about edge, I want to mention that. So this is a very important one. So these vehicles now is a computer and the sensors, right? So they are generating a tremendous amount of data. So this data projection gives you an idea about how many data that will be generated by this vehicle, by the prediction here. Imagine that this autonomous vehicle, connected vehicles, they will about contribute 17% of the total data generated by the world. That's a lot of data. And how can you deal with this data? So that was one of the challenges. So another thing is, if you're looking for individual vehicle, one particular autonomous vehicle, by the way, this was estimated by Intel in 2017, 5 years from today. So now actually even more than that. So each vehicle, individual, every day is generating 4 terabytes of data. So if you happen to taking a data science class, now you might get an idea that have you really deal with at a terabyte level before? Probably not. How many data you really have been seeing. So this is a huge amount of data. Imagine you have a LTE, 4G LTE or 5G. How long is it going to take to transfer this data to the cloud or to the server? That's going to take. You can do a little bit of math on this. Then you will see that that's just amazing. One day amount of data generated from a vehicle, you're going to take 10 days for you to transmit it to another places. That's the reason why you have to really need to do the processing here, on the vehicle, or maybe rely on some other infrastructures. So today, many of this running on the California, Michigan on the road, you saw this news. Actually, they're even generating much more data on this because right now it's an experimental platform. They're putting more necessary sensors on it. So the 35 terabytes of data. The computing itself can cost about 2K kilowatts. That is, imagine that. What does this really mean to you? 2 kilowatts, you probably don't have an idea, but then you can have in your microwave, most of your microwave probably is like 1 kilowatt, right? So this is just consume huge amount of energy. That goes to another interesting thing as a research topic here is how you going to be save the energy to building the energy efficient, the future vehicles. Imagine that you buy a Tesla, you're getting a huge battery, because the battery already costs about 1/3 of the cost of one electrical vehicle. Now, if this battery spending 20% of the energy is on the computing, on the sensing, that is not good. So what you want is maybe just 5%, but today's reality is it is about 20% if it's a fully autonomous vehicle. So that was a big challenge here faced by this new industry. So they have to deal with that. So here is, now I give you enough context. This is really about, in our 2000, last year, we wrote a paper called The Emergency of the Vehicle Computing. This is really a whole new area. There's a lot of things can be done. And this is not just computer science EE, including civil engineering, mechanical engineering, industrial system engineering. There's a lot of people can work in this. So basically, it's, you can think about it as a 4-tier. So because vehicle is not just a transportation tool anymore. Imagine that yesterday when I visited Oakland County, that's where I live, I was told they have 14 staff members. Their daily job is just driving the vehicle in the whole county, and then to check all these signals are okay, they are working perfectly fine. They're just to do this maintenance, collecting information. I told him, future, you don't need these people. Well, I'm not saying they lost their job, but they get something else. Okay, this is very expensive, by the way. You pay 14 people. Each of them drive a vehicle, drive around collecting this, right? Imagine if I have an autonomous vehicle, then I'm done, because autonomous vehicle can drive 24 times 7. Around this, the vehicle serving as a sensor. For example, when vehicle is driving on the road, vehicle have a sensor can even detect if you have a pothole, because we are in the northern part of the U.S. We know that how bad pothole is, right? You can rely on this vehicle to detect the pothole. Then you can, using this vehicle, talking to the infrastructure, for example, the IoT devices, next to you, you can sort of getting a sense about, this signal is working perfectly fine, because I was just told yesterday afternoon. If there is a traffic signal, every single, so first I want to tell you, none of you can even imagine that. Do you know how much it costs for per intersection? This is including the traffic light and the cabinet which controls this traffic light. So per intersection, a normal intersection in the United States, the cost is $250,000. Okay, you haven't got a chance to see what the cabinet look like. There's a lot of computing devices there, control this, and the proprietary software, and etc. Now, we need to upgrade this to the next level. So, for them, how do I know that every single traffic light is working perfectly, and even every single computing unit there is also working nicely? This, for them, is a big problem. If there is somebody reporting, traffic light intersection, one of them is down. If they're sending somebody there and come back, for the staff members, cost is the following: $200 per hour. So that's why for them, no time to on site to fix this diagnostic there. That's just a waste of money. When you see something wrong, just take it back, putting a new one. Then we come back, we have someone else look at these issues. So now you see, yesterday afternoon when I have a meeting, they said, I want one of your PhD students help us to solve this problem, because the whole Oakland County have about 2,000 intersections. The annual budget is $160 million. Is running all these things there. That is the way how this stuff is. Now you can see that the vehicle is here. The IoT, I'm sure you heard about these things. So vehicle, when they're driving around, they can talk to these people, collecting this data, and then they can do some real-time analysis. And if there's something wrong, they were sending a link, they were sending back to the cloud, immediately notifies them. So that was, the vehicle can do these things. But again, it's not necessary you have a human being driving these vehicles now. These things can be the vehicle, the city of Detroit can just have one vehicle driving around on their own, right? And then they don't need to go to sleep, because you don't need to. So what I said, this is a reality. It's not. City of Detroit actually hired 5 people, drive a van of all over the city to drive to check what's the status. That's what they're doing today. So that's just give you an idea that, you can do a lot lot of things. So that's so far. I hope you agree with me. There's one more thing that the vehicle is very powerful is even with vehicle. For example, my vehicle right now is parking at my garage, right? Even it's not a driving. This vehicle's computing devices is there, and the battery power there can also serving as a resources to do something else. So that's the idea. So you might heard about this, in the future. Now you are here. If Amazon is delivering stuff to you, to one of your apartments, you don't want them to lock your door, get it to your room. What you can do is you can let them just put in your package into your trunk. Everything is. This is part of another way of using the vehicle as a part of your computing. Because what you can do is, I can sit in here, just click a button, and then the deliverer can just put in my package into my trunk, and then I'm done. That. So you can see that the vehicle is, even before vehicle now is the computing unit can do a lot of things, even they are static, sitting at the home. It's not a driving. It's not necessary the vehicle is always is to function as a driving unit. So that's why I said that at the beginning of this talk, vehicle computing will be revolutionary, transformative of the whole industry. Can you imagine in the future, the following sentence is just my imagination, okay, not necessarily true today. How does a traditional OEM make money, like a GM? It's not the vehicle anymore. They sell software. That's I already mentioned, right? They can do following. Because every single vehicle GM sold out, if you want to deploy an app on that vehicle, and just like today, you download the app running on your iPhone, right? So you pay $10. Who got this $10? So you get paid $10, and 25% or 30% goes to Apple, right? So who is Apple in the future? GM is the Apple in the future. Because GM said, I'm providing you a iCar, right? So I'm collecting all the applications that are running on your vehicle. GM said, I have an interface here. I allow you to using my data to do the computing here. So you need to pay me money. So GM is going to collect some money. Eventually, I feel that all the OEMs, the biggest revenue for them is through this. Vehicle is free. Okay, I don't need to charge you a vehicle, barely minimum. I give you a vehicle, you got it, and then I'm collecting money through this business model. That will be the way. The earlier the OEM going to change their mind, they will be standing on the frontier. If you are still doing the old school, I guess the time will be coming soon that you will be fading away, just like a Kodak Kodak, and right. So that's something why I think it's so excited about this. The whole thing is changing. You have to really think about that. Really admire you as a young graduate student, because you are hitting right on time right now. There's a lot of things need to be changed here. So next I show you software-defined vehicle. I already mentioned software-defined vehicle is the future. This will be a word. If today is the first time you heard this word, which is good, maybe you already read it from somewhere. Imagine the future. The vehicle here is you have a lot of safety services. Obviously, is important, and then you have other mobility services. You can do path planning, intersection control. Eventually, the ideal world is no traffic at night, right? You just go, and then that was still a long time to go. And then you have some other information service. For example, this is the way how do you maintain on a vehicle. The last thing is you can do a lot of non-vehicle related stuff. For example, you can do in-vehicle delivery. You can do in-vehicle meetings. So for example, car is driving by themselves. What do you need? You need even much nice immersive environment to play games with people or have a meeting with people. Those things eventually going to be in your GM. I think they invest in another company. Cruise automation was part of GM owned. The other one is called the Bridge Drop. The Bridge Drop is another one is called for the food delivery. There in the future all this food delivery will be done by this and by the autonomous vehicle. That was you can serve a lot of this extra services here. So here is I show you now you're understanding the services. So who are the key players eventually in the vehicle computing? In other words, imagine that you have a vehicle, you're running a lot of services here. You also make money. So today when you have a vehicle, you never make money, right? Because you are just a consumer. But the future way is I using these big coins here to show you that. For example, city government, in order to improve the city, we pay tax to them, right? And city government need to have some services to you. So they using the taxpayers' money, which is coming from us, and then they go to say, I want to run all these services. I pay the service provider, which is a cloud provider. They provide all kinds of services. And then the cloud provider will give these services to, infrastructure, hardware, software, telecom, and etc. And then this guy, after they collect the money, they need to pay the automakers, OEMs, because OEMs need to collecting, said, you are running these services on my vehicle, you should pay me. And then the vehicle will be saying that, well, although I'm running this vehicle, but it is my car who drive around to help you to collecting this data, do the computing. You should pay me. So eventually, you as an owner, you can collecting the last piece. But it is good. So if you don't believe this, let me tell you another, sector of industry. Do you know that in Germany today is a lot of houses, they don't pay any the energy bills for the electricity. That's the ideal case, 0. Why? Because many of the companies, many of the householders, they put in solar power, they put in wind, microgrid, they deploy it in their house. And then if they're not using this, they sell this back to the grid. And then now in some region, the money, the revenue that generated by selling this electricity is already balanced the total electricity cost by this family. Now you pay 0 now. This is not like a fiction here we're thinking about. It is. Well, I don't know whether you can get all the money, pay off this whole vehicle, but there potentially is you might be paying certain amount of money getting the vehicle, but then you are making something. The more services you are doing, the more revenue you are generating. So that's very different from where we are today. So that's some of this is just using my imagination to share with you. But some of this might be, it's going to be coming true very, very quickly. That. So, for example, I give you one service. One service running could be by police department running for the Amber Alert. We all know Amber Alert, right? If somebody is missing, today's Amber Alert, they're doing is putting on a sign, your cell phone got it. But why not we running an Amber Alert on all these vehicles on the street? Then you can very quickly identify, I saw this potential people, right? Because your vehicle already equipped with back camera, front camera. You have a lot of things. You can do this kind of analysis. But if you are running this Amber Alert on your service, you might be getting some, sort of incentive to do this. So that just give you an idea. And then we go to, there's a lot of challenges. Well, that's a beautiful picture I painted here, but they're not all of a sudden going to become tonight, right? There's a lot of challenges. I think this is a very important slide I want to share you. So as a PhD students, master students, you can pick any of this topic to starting your writing your thesis, writing your paper. For example, what are the future vehicle workload going to look like? Nobody knows. If you are in computer science, you know that before we design any CPU, we need to understand what's the workload, right? Then you can design the best chip to serve this. But what's the future vehicle workload going to look like? Right now, it's not very clear. So that was the first one. Second is if you are working on communication, that's a huge, it's a area that people are working on. What does CV2X really mean? Can we really using this and to do some stuff? At the Winston campus, I team up with a startup company. We just getting a award from state of Michigan. We will deploy at the 3 intersections, kind of covered with a CV2X, and then the students were allowed to. You can read this information. See what can you do. For example, if I'm sitting here, I can read that next signal to me in the next 30 seconds. What going to be doing here? So imagine what's the possibilities. There's this is a very exciting moment. We don't know. People need to be very innovative here. Is if you can sitting from your vehicle, you know that exactly how long that vehicle, the traffic light is going. You maybe can do a lot of things there. So program. Now you have a vehicle, you have an edge server, you might have a cloud. So how do I write up code for this? Amazon got to hire you if you are joining Amazon Automotive. they will tell you, wow, you need to know that how can we develop the tools for the people to writing code for the auto industry. Because auto industry will be, you're not going to be writing a line of code here just for one server, right? You know, if you have a GM vehicle, you know there's an OnStar Guardian, right? OnStar Guardian is something running on your vehicle, something running at the edge server, and then running on the cloud. How do you going to be writing a code? Can you, ideally, if you can writing a code, you just describe the function, and then they automatically deploy it there. So that was a challenge. You know, I also talking about the runtime scheduling here. Energy consumption, I already explained to you, very important, because this device is consuming a huge amount of energy on the vehicle. We need to reduce that. And then safety, security, you heard about that. So imagine how can you implement a function so the Amazon deliverer can open your trunk and then put in the stuff there without sacrificing some other stuff. So that is important. And then if you are really working on the vehicle alone, end-to-end optimization is very important. For example, one of my PhD students working with me said, Dr. Shi, here is my, very important, you know, autonomous driving using a lot of machine learning, deep learning, right, to do this. I want to optimize it. And then I asked them, okay, tell me, if originally the latency for this machine learning is 100 milliseconds, tell me that how much you can optimize. You know, what's the percentage you can do? He said, I probably can increase to 15%. That sounds like a very good number. But then I told him, look, the machine learning itself is 100 milliseconds. You cut it to 15%. Now, let's say 85, right? Do you know that why we need the machine learning here? It's because we want to run this, eventually make a decision to change and control this vehicle to do something, correct? So when you do these things, the whole end-to-end latency, do you know what's the total here? You need to include the computing cost here. Sometimes maybe you need the communication here. Eventually, there's a control overhead here as well. That's what we call vehicle dynamics. So even you give a signal to the vehicle, let's turn. Okay, vehicle needs to turn, but this is a physical entity here. It takes time. So I told him that today, your optimization 15% means nothing to a real vehicle, because the vehicle here itself, for example, you give an instruction to the bus, let them to turn, itself waiting 300 milliseconds. So that's what's today's vehicle. Hardware is physically sitting here. You can even remove all the machine learning cost. You still have 300 here, plus the communication and et cetera. So this just gives an idea that when you want to do optimization here, it's really important for you to consider the whole spectrum. Because eventually, if you want to sell your idea to GM, for example, if you want to start a company, if you just say, oh, I'm just optimizing my machine learning algorithm, nobody's going to buy you, because machine learning algorithm is not the bottleneck today. It's not the bottleneck for vehicle today. So, but this doesn't mean you don't work on that. I'm just giving you an example to have a big picture about before you decide to do any optimization here, you have to really have a good understanding here. The last thing I talk about is the business model, because nobody is clear about how the vehicle, eventually going to be, who's going to be making money and who is not. So that's why you can see every day you read the news. Today is, for example, Ford is a partner with Google. Tomorrow you see Verizon is team up with BMW probably. So that there are all sort of this news. It's because they are all trying to understanding that what is the right way to handle this new wave of the things is coming. So this is not very clear. That there's a lot of interesting challenges here. Next, I will talk about some of this edge intelligence, but I want to stop here in case you have any questions related to vehicle stuff. Any questions? Good.
Regarding the security or the reliability of the software, people are going to be downloading to the vehicle and control some of the functionality of the vehicle. So how we could verify there's no bug in the software that would cause some big issue. When I taught the software engineering, that seems to be a unsolved problem.
Absolutely, and even right now, when your vehicle is getting a new software, individually is already have a huge challenge there. You know, because vehicle is the most complicated entity humankind has been made. Right? There are about 6 million line of code. You guys probably future going to contribute to this. It's very complicated, and now we're even talking about more functions, and then you are downloading from there. So I think from the it is an interesting research, and now you can see a lot of recently there's papers come out. You know, what are the people doing? One of my students, for example, is just a portion of is a trusted execution environment. So you can download this stuff, but we put you in a very isolated environment around this. So no matter what you do, you're not going to affect my mission critical stuff. So future vehicles, the computing unit will be look like this. So today you probably have 140 ECUs, each like your window, you know, your door. Each of them have the separate. In the future, will be have a big, pretty powerful computing unit. They will be using software-defined way to control all these 140 ECUs. And then there's another one. I still think, but not necessarily everybody agree. We need to have another one, dedicated hardware to run this vehicle driving functions, because that one is so critical. If you don't treat it well, you know, somebody else can run something, take all your resources, and then your vehicle is not enough responding. Putting a malicious software, putting a bug here, continuously consume all of your computing resources, and then your vehicle don't even have time to drive. That will be very dangerous. So those are the new dimension of challenges, in addition to what you mentioned there. So it is a lot of new challenges here. Okay, so I will move on to the next, because I think I already finished the majority of this talk. The next thing is relatively easier. So I want to show you that, you know, why, if you haven't heard about edge computing, how many of you heard about edge computing before? Okay, only some of you, that's good. So I want to give you an idea that why edge computing was starting to pump up as a research area. So think about by the time 2015, so why 2015 is unique is because let's go back 10 years before 2016. In December 2004, IBM make a very big news. IBM decided to sell their whole PC division to Lenovo. You guys know Lenovo, right? Good. You know, Lenovo is a company who spin off of an institute from Chinese Academy of Sciences. It's where I did my PhD. So actually, I know the Lenovo whole executive, you know, this team very well because they were spin off from our institute. So Lenovo in the 2005, sort of that time frame, they purchased IBM. One of the biggest things is the thinking pad. If you are senior enough, you know, think how good of thinking pad. IBM thinking pad is just like nobody else can compete with that. It's so good, reputation there. But why all of us, when we heard about this news, we were surprised. What? Why IBM sold thinking pad, everything to Lenovo? You know, Lenovo was really nothing at that time. That is an indication. IBM already realized. Remember, IBM is the company who come out the term PC. You know, today we're using PC, right? What does the PC stand for? Personal computer. That was 1980 when IBM introduced the first PC. So they have been contributed so significantly. 25 years later, they decided, I'm not going to do this. Sell it. Because they realized that the future of this is, they didn't call cloud at that time. They called services. You know, everything will be service. Software as a service. Everything as a service. Okay. So there's no meaning for them to continue to sell desktop, because laptop, because this you're not making money. So that there's the revenue is very low for a computer in this. That's why Dell, HP, and Lenovo, none of them was like, I guess you don't really think those are really high-tech company, right? You just getting one of the computers from them. That happens. 2005, cloud computing just the beginning. 10 years later to 2015, things is changing significantly. The cloud has been penetrated to our daily life, including the way you check email. Nowadays, you guys all online in your cloud. The way you store your stuff, share a document with your classmates, Dropbox, Box, Drive, right? Everything is changed. So the cloud computing is dominant. So now, even as a cloud provider, for example, if you are the CEO of Microsoft, what are you going to think about? You need to think about the next thing. So next thing is here. Now, dial back 7 years ago, And next thing is, first thing, as a cloud provider, it's very important for them to think about, now, the whole world is relying on us, Amazon, Amazon, Microsoft, Google. So they want to deliver all this service to every single corner of this planet, 30 milliseconds. How can they do that? That was a challenge, right? Otherwise, you don't want to be too slow. You want to be 30 milliseconds here. And the other thing is, you can't just rely on one data center, because like a Tesla happens a couple of months ago. Many drivers, the customers, they cannot start their vehicle. Why? Because it is the server on that side that has something wrong there. So you need to improve the availability, reliability there. The third one is the bandwidth, because there are huge, everything before from 2005 to 2015 is you collecting data. You all this shipped to the data center. When I say shipped, it means you can transmit it, okay? But this is a huge data is here, and then who will pay for this bandwidth? So because of this, cloud providers, it's them really want to push into the next thing, which is edge computing, okay? So the next one, I think many people from academia, they understand it is much easier, because you have IoTs, you generate a lot of data. So I want to make some local decisions. IBM calling this real-time context computing, but not many people are aware of this concept. But it's just different companies at that time is trying to come up with a term here. Basic idea is you have a vehicle, you need to make a real-time analysis, for this. For example, a aircraft. If you fly from here to London, from here, do you know how many data they were generated? All these sensors. So they can do is real time do the analysis. And then if their engine has a problem, they can take action immediately. So that was the real motivation. Edge is there. One is IoT said I need an edge here to help me process, make a local decisions. Cloud said I need an edge in order to push my service as close as possible, close and fast to these end users. So that is where edge computing comes from. So this is a figure, that in our paper we draw. This is just to show you that you are not just a data consumer. You are also a data producer. So then the data moving from here is a large amount of data, and through the edge is getting smaller and smaller. And that's the idea. This is to show you that what you can do here. You can do a lot of things. Today, even people working in security, they're using edge computing to do this attacks, analysis. In the national backbone network, they need to detect as early as possible, so then they can isolate this network in case there is somebody doing cyber attack. That was the idea. And then you can see that I don't have time to go one by one. If you're interested, you can read this. Even today, a lot of challenges I mentioned here is still there. And then we go to next slides. So edge computing in the last 7 years, 6 years technically, has been widely being adopted by different industry sectors. So today, you can think about is everybody was recognized is a 3-tier computing. So you starting with IoT on this side, and then you through different communication channels. For example, one of the projects we are working with a company in Ann Arbor is we deploy a lot of LoRa-based sensors on Lake Erie, Lake St. Clair. And then using LoRa can transmit 3 miles away. Then we collecting this data to looking for the water quantities that are shared by Toledo, Detroit, and etc. So those are the different ways. And then you go to an edge, do some local process. Sometimes it's not enough. You go to the cloud. So basically, that's the sort of 3-tier architecture here to show you that. One thing I want to mention here is in the edge computing, the edge is not a fixed device. For example, if you are working on health, for example, body area network, you deploy some sensors, you eat some sensors inside, right, to clean your vessels, some stuff inside, and then your smartphone, it will be an edge. Because smartphone, imagine that today you can, in the medical field, you can take a pill and the inside, and then they can clean your blood, not real blood, clean some I think it's obstacles along your the movement of the blood, and then you can using a smartphone here just to show the real-time image of what's going on inside of the body. This is not a fiction. It's already some of people is already doing this. So in this case, your smartphone is an edge server. Okay. Now, in some cases, your vehicle is an edge server. But if you are talking about, for example, Toyota, if you are talking about, I have 50 million vehicles running globally, and then I need to collect the data to do the things, that vehicle is just an IoT device for them. So for them, cellular tower is their edge. So that just give you an idea that different context, the edge is different. You can always think about edge is something close to you, but it's much more powerful than yours. They can make a local decision. So that's a sort of give you an idea here. So in case you are interested in the edge computing, just now, Professor Abbas already mentioned that what if you are faculty here interested in this, I still encourage you to go to, in 2016, myself with Professor Mu Chang, who is Dean of Purdue right now, he and I are the co-chair, and then we're running an NSF workshop on grand challenges of edge computing. Then we're writing a report to NSF. In the last few years, NSF have created several new programs. For example, with Intel, with VMware, they created new, edge computing programs so that people can apply. And then there's another one. We're also starting a new conference after this workshop. It's called the SEC. Right now, it has been considered as the top tier area. If you're working in the edge computing, or if you want to read the papers, this is the conference. You need to read the paper. If you don't have time to read so many others. So it's going to be, our goal is really trying to define this field, as you can see that from the beginning of this. And then if you are interested to read some challenges, even this paper today, you can still read it. And also, if you're teaching a class, you want to run a seminar on edge computing, Proceedings of the IEEE invited me to organize a special issue in August 2019. Then we have 13 survey papers, which cover almost everything before this deadline. So it's a very good one. I know in many some universities using the seminar, like Buffalo, like some other Central Florida, they are using that as a classroom materials because that's enough to cover for the whole class. So that just give you an idea about that. Now we move to, we already know the edge. Now what are you going to do at the edge? So ideally, it's very simple. Is you can do something. I just using one slide here to show you that edge intelligence really mean to us. So you can run some AI here, but what you can do is imagine that in the cloud computing you have a dedicated hardware. Google design TPU, Amazon develop their own stuff, Microsoft designs their own stuff. They are building their own servers these days. Then each of them come with their own software. Like Facebook have a PyTorch, Google have a Tencent, right? You might heard about this. And then on top of this, they have an algorithm. I don't want to cover too deep because I noticed that today known that this is an EECS department. If you are not in the background, you probably not really buy this. But the good idea is, this is what's happening in the cloud. Now, if you want to move this to the edge, they pretty much have exactly the same thing here, but it's just at a lower level. So what I want to tell you from this figure is, edge computing, when we proposed in 2015, that is a huge, it's another even a huge area because looking for that, who is designing this? The edge devices today. The edge devices, for example, Qualcomm, they even have a lot of startup today. For example, if you now know how to design a good chip for the edge, so you can start up a company today. Maybe later on, Qualcomm, Intel are going to be buying you, acquire this company. There's opportunities there. And then each of the software framework come with Tencent Lite, come with a PyTorch, and they have their lighter version because it's running in a much smaller kind of factor forms. And then on top of this, you can do a lot of optimizations. For example, originally, if you are working in this domain, you know that it's a big network. It's a very, very big, like 240 megabytes. Now, you'll be asked to running this in a microcontroller for this guy. So the maximum is, 100K. Now, what do you do? So you need to think about, now is a very popular topic called tiny ML. Tiny ML. Tiny ML is a very hot topic if you are working in this field. Just to give you an idea that eventually those tiny ML can run many of these places to make sort of decisions and etc. Okay, so I will go because I see I already run out of time here. So that is perfectly fine. I just want to give you one more last the idea that here I can go a little bit fast about because I came here, I really want to share with you that some of the work we have been doing in our lab, and in case we have a faculty, we have a PhD students who want to do some collaboration here, right? So we started working in the vehicle about, I still remember, in December 2017. So at that time, I think that I get a sense about that, the future of vehicle, computer science have a big say there. So no matter other people, what do you think? I think that way. So we created this lab, car lab, connected autonomous. Even this logo I designed myself. The future vehicle is much smaller here. Did you see that? And then you can see that it comes with eyes, come with this self. I designed this logo myself. That will be the future of this. And then, first thing I realized is, in many of the computer science EE department, if now we have a student working in this domain, we don't have a hardware to play with. So that's why we designed this Hydra 1 platform, and then from students starting from every school to build this ourselves. By the way, there's a couple of universities in US already make an order, purchase this. One of our colleagues in Rahway University, New Jersey, they just got a 1.2 CPS grant. They're going to purchase 4 of this. I asked one of my postdocs to start a company, so we are selling this now. So that to sell to them, they use this as their research platforms. University of Toronto, Ohio State, they all showed interest to getting this. So that was the first thing we built because we needed this. Then we started putting more and more. This is another platform. So for example, this is one we have. I named the Zebra T, so that they can, for the food delivery, you can run this. This one can really run it outside. And then we also have, assembly this platform. So it's a full stack. Is a with some company donated sensors, and I also have some other money. So we're putting this together. So today we can drive this. It's an autonomous vehicle. So next time if you have a chance to visit us, you can sit in here. They will tell you in the parking lot just on your own. So those are the platforms that we have, plus the one I mentioned, the CV2X infrastructure. So keep this in mind in the future, to the faculty and the students. If you think, we need to run some of this experiment, we want to do, writing papers, you can contact me. Then you're not far away from here. You can even just go there, do some experiments. We can collaborate. Okay. So I think that's. I will stop here because I still have some slides, but I don't think we need to cover that. So I want to maybe take some questions from you. Thank you so much for your attention.
Thank you. Thank you very much for the very nice presentation.
Sure.
So questions?
Yeah, I can show here. This is Detroit. Oh, by the way, where the wind state is, we are here. This is 94. This is 75. So we are. Let me try to figure out. Okay, I think it's here. This is where my office is. Okay, this is the Detroit River. Of course, this is Canada. So just to give you an idea about, we are working very closely with the city of Detroit so that some of this video data that we can get into the stuff. All right, good. Questions? Any questions you want to ask? Go ahead.
So for your projects like the Zebra T, what field use have they undergone? So they've been used for any actual deliveries, or what kind of testing have you done for the city?
You mean for our work with the city of Detroit?
So have they made any deliveries of anything, like the Zebra T specifically?
Oh, no, the Zebra T platform. No. We haven't really delivered anything. The reason we built that is it's a full stack. So and that one, if you remember the previous one, Hydra 1 don't really have a CAN bus, but it's all-wheel drive, but it's all controlled by Arduino. So we need to understanding that how the control. Remember I mentioned the latency. So we built that platform purely just for the students to do some algorithm energy efficiency study. For example, every single charge you are go to this road. You can do energy efficient path planning, and also you can do one of the things is a computer vision, using this vision to control sending back. So he wants getting a sense about the total latency, etc. So we are doing this purpose. We are not really deliver anything. Yeah. Good.
So currently how roads are kind of designed for humans, like the stop signs and stoplights and all that. To you, what would roads and highways look like if they're specifically designed for autonomous vehicles?
That's you are really future thinking. So have you get a chance to view, if you have a chance to go to some place, I never be there. I heard, for example, in the Middle East, Abu Dhabi, what they do is, they create a new area. Say, okay, this is a future city. If they're doing this, the things will be much different because all the vehicles running here are autonomous vehicles. That is much easier because you don't even need to have a sign here anymore, right? Just a signal generated there. And even you don't need a signal, you probably can. You run a simulation, somebody is just sending the signal there. That's all futuristic. But today, it will take a while, and that we still have human drivers. The real challenge is you always deal with, next 30 years, I don't think all the vehicle can go the other way, right? So you still have all these things together. So that will become a challenge is how do you deal with this? You mentioned a very important research topic. That was yesterday when I visited Oakland County Road Commissioner. Because we found out that today, those adaptive traffic signals is, if they see there's a lot of traffic is going this way, they can extend the length of the green light for this direction. But now, when they do this autonomous driving testing, they found that there's a big deal here is when they do this, they give you this amount of time. They give you, for example, more time. Then assume you can all turn to the other way. But then now there's an autonomous vehicle is coming here. They don't really, for some reason, they're not like humans here. And then he told me that in one of the experiments, they only give that vehicle 13 seconds. Something wrong, and then the car was hit by another vehicle. So the point here is many of the things, like you said, was designed for the humans, but now we're talking about all these things for the future vehicles. So there's a lot of interesting things here. You could, that could be a very good topic to start to study. Yeah. Yeah. No question from this side. It's because I always turn this side. Sorry, now I turn this way.
Any other questions?
Okay.
Can you amplify the aspect of the policing part of the vehicles? Like, for example, in most cases we see empty parking lots. They are ideal platforms for criminal and other kind of activities. So can you emphasize that part of the vehicle computing, like how they can monitor and help local authorities in terms of security?
I'm glad you mentioned that. We actually next week I have a meeting with the OnStar Guardian team. OnStar Guardian team now is in the middle of talking to us. Is they want to deploy this at Wayne State campus. It's not just for vehicle anymore. It's for all of us. And then one of the ideas is, if during the evening, if you are working on this way, there's very less traffic. There's a potential risk here, right? So then they can automatically call for a police vehicle. Imagine, because we are working with the chief holder, Wayne State Police, the chief for the university. He's very by this idea. I told him, hey, why don't you buy an autonomous vehicle? And then if somebody is working till the 12 p.m., want to go home, and they just push a button, and then this autonomous vehicle just go with him, and then escort him to back. And if you see, like you said, there's an empty parking lot, nobody is here, with a few cars here, you see how dangerous. Then we can send in the autonomous vehicle, just come here, drive around. That is already on the agenda. It is on the agenda, but so far it's more like a pilot. Wayne State campus, we're in the middle of talking about this right now, because the OnStar Guardian team is, we are in the middle of discussing this. Yeah, I really want them to using an autonomous vehicle to really doing the center around the campus, and then because that way you don't need a human beings. Even in the evening, just drive around slowly, right? Some of my students actually now they're working till like 12. Not that I ask them to go there. They just work. They want to debug their code, but they like to stay there. But it's really good. Yeah. Sure.
Okay, if there is no other question, let's thank our speaker once again.
All right.
Thank you very much.
Thank you.
Thank you.
Oh yeah, did I mention that here is my email address. So in case you want to approach me or anything, yeah. If you're interested in some of these papers, you can read it. Okay. Thank you so much.
Thank you very much.
Okay.